Hi class, this is Neil and this is lesson 1, introducing I. Alright, for our do now, we're asked to determine the value of each of the following expressions. Square root of 25, that equals 5. And that's because, as we know, 5 squared, which is 5 times 5 equals 25. However, if I try to find the square root of negative 25, I get a message in my calculator that says undefined. Or error. You might see error in your calculator. Negative square root of 25. Well, because that negative is on the outside, it's just the negative, whatever the square root of 25 is, which is 5. Cube root of 8, that's just equal to 2. Because 2 times 2 times 2 equals 8. And the cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 equals negative 8. All right, question 2, we're asked to solve the following equation for all values of x. All right, I've got this polynomial here with 4 terms. I'm going to have to do some sort of factoring. Anytime I see a polynomial with 4 terms, what my head always goes is I want to try the factoring by grouping method. So I'm going to look for a greatest common factor on these first 2 terms, x cubed and 3x squared. That's going to be x squared. So I divide that out, and I'll have x plus 3. Then I'm going to look for a GCF for the next 2 terms, and I've got minus 4. 4 is the GCF, times x plus 3 equals 0. All right, so now I've got x squared minus 4 times, I'm going to group these 2 together, x plus 3 equals 0. And now I'm just going to set each side of this equation equal to 0. So x squared minus 4 equals 0, x plus 3 equals 0. All right, if I solve that easier one, x plus 3 equals 0, subtract 3 from both sides, I'm going to get x equals negative 3. For x squared minus 4, I can add 4 to both sides. I'll get x squared equals 4. And now when I take the square root of both sides to solve for x, one thing I have to remember is that my solution for x can either be positive or negative 2. In Desmos, we want to enter that as negative 3, negative 2, 2. We want to list them as a set, a solution set. Now, one thing to notice is that the degree of my function here, the degree is the highest exponent, the largest exponent. Our degree here is 3. One thing you might notice is that the degree is 3, and we also have here 3 solutions to our equation. Now this kind of connects us to what's called the fundamental theorem of algebra. And basically what that theorem says is that the degree of the function, the degree of the polynomial, let's say that's n, is going to be the same as the number of solutions, n. So one thing I might think about is if I have a polynomial with degree 3, I know I'm going to get 3 solutions. And this is a fundamental theorem, meaning it's central. It's so important to algebra that we can't ignore it. If I see this next question then, before we even answer it, solve the equation x squared plus 1 equals 0 for all values of x. The degree of this function is 2. My degree is 2, meaning that I should have two solutions. Not I should, but I must. I must have two solutions. Okay, so let's solve our equation here. X squared plus 1 equals 0. All right, so I'm going to subtract 1 from both sides. I'm going to get x squared equals -1. And now I'm going to square root that. But when you put that in your calculator, you're going to get error or undefined. But that's a problem, because that goes against what we call the fundamental theorem of algebra, which says we must have two solutions. We have to. So I'm going to say that the solution to this equation is I. And because we need two of them, I'm going to say that it's both positive I and negative I. These are my two solutions. Now, what did I just do? Well, I introduced you to this idea of I, and I is equal to the square root of -1. This is just a nice little trick for me to get around the idea that that square root of -1 is undefined. If I define it as I, then I've given it a name, and it stops being such a big problem for us. All right, determine the square root of -4. Let's see how we can apply this idea of square root of -1 equals I to this next problem. Determine the square root of -4. All right, so square root of -4. Is there a way that I can separate that out so somehow I isolate the square root of -1? Well, I could rewrite that as the square root of 4 times -1. That's just the same thing as the square root of 4 times the square root of -1. And now what you should notice is that I've created or rewritten my expression so that I have square root of -1 all by itself. Square root of 4 I can simplify to 2. Square root of -1 is I. So this is my solution. All right, square root of -9. Well, I can rewrite that as the square root of -9 is equal to the square root of 9 times -1. If I separate that out again, I've got the square root of -9 times the square root of -1. Square root of 9 I know is 3. Square root of -1 is I. Okay, determine each of the following. Square root of -16. Okay, so that equals, if I separate it out, 16 times -1. Separate it again, I've got the square root of 16 times the square root of -1. Square root of 16 is 4. Square root of -1 is I. All right, something important to notice here. Here I have that square root on the outside. I'm sorry, the negative sign on the outside. So actually, because the negative's on the outside, it doesn't affect the value of my square root. I'm not going to have an I there. I can just take the square root of 16, which is 4. But I can't forget that negative sign on the outside. All right, in the lesson we did a lightning round. Very quickly I can kind of go through these. Square root of 36 we know is just 6. Square root of -1 we said was I. Square root of -81 I can rewrite as the square root of 81 times square root of -1, which is 9I. Negative square root of 1, I can just rewrite that as -1. Square root of -100, well, I can rewrite that as 100 times square root of -1, so that's 10I. Now the only difference, the only difference between E and F is I have this negative on the outside, so I'm just going to add -10I, because that -100 is the same. Square root of negative 144. Well, that's just 12i. All right, square root of negative 40. Now, we could say that it's I square root of 40. But from previous units, we can see that I can actually simplify that square root of 40. So I'm going to write I on the outside times 2 times 2 times 5 times 2. So basically what I did there is factored 40. I'm going to circle my two 2's there. This is the jailbreak method. I take 2 out, but one of them dies on the way. So I have 2i square root of 10. And that's actually my final answer. All right, so if I look at question 5 then in the lesson, this is just a way for us to kind of review again what we did in that last problem in the lightning round. So square root of negative 27, I can write that as I times square root 27. Now I can break 27 down into 3 times 3 times 3. Then using my jailbreak method, I circle 2. 2 try to escape, but 1 dies in the process. So I have 3i square root of 3. And that's my answer for that question. All right, solve the equation x squared plus 25 equals 0 for all values of x. So this is just slightly different, but connected to that very first problem we did. If I solve this for x, get x by itself, get x squared equals negative 25, but now if I square root both sides, I'm going to get x equals, now remember we have to have two solutions here, positive or negative. Square root of 25 is just 5, and then remember this has really a 25 and a negative 1 in it, so square root of negative 1 is always I. When you enter this into Desmos, you want to write 5i or negative 5i. All right, and that's all we're going to review in the video portion of the lesson. There's 4 problems from the important stuff that I'd like you to try.